So we've got kind of a theoretical question here. Can we show that the derivative of an even function is an odd function? Well, to do that, we need to start with the definition. An even function, f, is one where f of x is equal to f of negative x. And an odd function, called g, is one where g of x is equal to negative g of negative x. So our question asks about the derivative of an even function, so that's where we'll start. Right? We'll say let f be an even function, so we know that f of x is equal to f of negative x by definition. And I'm going to differentiate both sides of this equation. Right now, if I do that to the left side, the derivative is just f prime of x, and we're done. On the right side, this is the side where we're going to have to use the chain rule. Right? Because we have one function f, and it is a function of another function, negative x. So the derivative, according to the chain rule, is going to be f prime of negative x times the derivative of kind of that inside function, the derivative of negative x. Well, derivative of negative x, that's easy enough. That's just negative 1. So that means f prime of x is equal to negative f prime of negative x, and that's what we needed to show. If you really want to see the direct fit into the definition, replace f prime with g, right, and you'll see that it does match that definition of an odd function. So if you want to see the full context, the bottom, one of the links on the bottom here will take you to the lecture on the chain rule. And if you like this example, please don't forget to click on the like button below as well.